How's it going, you guys? In this video, we're going to be talking more about solving with absolute values. So I'm going to run through a couple of these, just kind of refresh your memory about what we talked about last section. So remember, if we have the absolute value of x minus 1, that means that either x minus 1 is equal to 10 or x minus 1 could be equal to negative 10. So that way it would be absolute value of negative 10 is 10 and the absolute value of 10 is 10. So in solving both of these, we could have 11. So we add 1, add 1. Add 1, add 1, or x could be negative 9. Both of those are possible solutions. Likewise, here, except I don't have my absolute value alone by itself right now, so what we need to do first is divide both sides by negative 3. So negative 3, negative 3, so the absolute value of y plus 1 is 4. Now that I have the absolute value by itself, I can say y plus 1 is either equal to 4 or y plus 1 is equal to negative 4. So and again, subtract 1 from both sides in this case. So minus 1, y could be 3, and minus 1, y could be negative 5. Either way, both good possible options. Another one, same idea, except I have more stuff that's keeping me from having the absolute value by itself. So first thing I want to do is I want to go ahead and add this 8 to the other side. So I have 4 times the absolute value of 2x plus 7, absolute value, equals to 20. Now my 4 is stopping me from having the absolute value by itself, so divide by 4, divide by 4. We have the absolute value of 2x plus 7 equals 5. And then I will drop the absolute value, so it could be 2x plus 7 is equal to 5. 2x plus 7 is equal to negative 5. I will have to subtract 7 from both sides, so minus 7, 2x equals negative 2. And minus 7, 2x equals negative 12. Divide by 2, so x is negative 1, or x is negative 6. Those are both possible options. All right, different kind of thing that you're going to be seeing in tonight's homework. Write an absolute value equation so that, what? Words. Okay, write an absolute value equation that has the given solutions. Okay, so it's telling us these are solutions, negative 4 and 4. So we could have an absolute value equal to 4. So that way when we actually solve it, we could say x is equal to 4 or x is equal to negative 4. Yay. All right, here I want negative 3 and 5. So thinking about this, these are both 4 away from the number 1. So what I can do is I can say x minus 1 is supposed to be 4 units away. So again, sometimes I have to solve these to make sure I'm doing them the right way. So if we solve this, x minus 1 is equal to 4, or x minus 1 is equal to negative 4. So if I add 1, so plus 1, x is 5, and x is negative 3. So I have negative 3 and 5. I know my solutions are good, so my equations are good. So that was an equation. That was an equation that had those solutions. That's what it's looking for there. All right, moving on. Remember, you guys can pause the video, go back to the video, rewind, listen to me say it again and again and again as many times as you want. That's what these things are here to help you do. All right, now we're looking at inequalities, and we are going to graph the solution. So we're going to graph our possibilities. So now in this one, again, make sure your absolute value is by itself first. So go ahead and divide by 4 on both sides. So we have 2y plus 5 is greater than or equal to 5. Then I can take my absolute value out and say 2y plus 5 is greater than 5, or 2y plus 5 is less than or equal to negative 5. And we will solve those just like we're used to solving. So if I subtract 5, 2y is greater than or equal to 0, which means y is greater than or equal to 0. Subtract 5, so 2y is less than negative 10. Divide by 2, so y is less than or equal to negative 5. So when I'm talking about graphing the solution, all that means is I want you to throw it on a number line. So remember, the number line deals with 0 and positive number there. So right, we have 1, 2, so on and so forth. We have 5 over here. We have 0. So now it says or equal to right here, greater than or equal to 0, less than or equal to negative 5. So if I want to be greater than 0, it's going to be going that direction. Less than negative 5, oops, that's positive 5. Negative 5 is right there. So if I have less than negative 5, I'm going to be going that direction from negative 5. So I could have anything over there. I can have anything in that direction. That's what I'm looking for when I see graphs. So it says y is less than negative 5, so y is less than or equal to negative 5. and y is greater than or equal to 0, so y is greater than or equal to 0. All the numbers greater than 0. To write this in interval notation, we have everything from negative infinity to negative 5, and then from 0 to infinity. Cool. So this is solving it. This is graphing it. I'm going to be looking for both those things if it asks for both of those things. So let's do them another one. Same sort of idea. Don't look down there. No. Don't do it. Don't do it. You don't want to read those directions. Yeah. Oh, yeah. All right. So same sort of deal. I want to get the absolute value by itself. So divide by 2 first. Divide by 2. And we have the absolute value of 3w minus 1 is less than 4. Now I can draw my absolute value by saying either 3w minus 1 is less than 4 and 3w plus, sorry, that should be minus 1 is greater than negative 4. Right? Switch the sign and change the sign. So change the direction of that sign and change the sign here. So now solve both of these, so add 1, so 3w is less than 5. Add 1, so 3w is greater than negative 3. So w is greater than negative 1, and w is less than 5/3. So on a number line, 5/3 is like 1 2/3. So we have 5/3 here, and it says just less than, so I'm not equal to that point, and I want to be going that direction from 5/3. I also have to be greater than negative 1, so if I'm greater than negative 1 is open, and greater than negative 1 will be going that direction. So since they're going towards each other, I just want what's in the middle such that it'll make it true. So even if you pick like 0 or something, 3 times 0 is 0, minus 1 is negative 1. The absolute value of negative 1 is 1, which is less than 4, so that works. So we have the solution set from negative 1 to 5/3. These are your solutions. Anything in that range will work for our equation. This is how you graph it. All right. Write an absolute value inequality to describe each graph. I haven't done the graphs yet. All right, graph. I'm going to graph. I promise. I'm going to graph. Woo! Yeah, graph. Okay, so on this one, notice I have everything. It'll help if you kind of write your inequalities, because I have everything less than or equal to negative 1. I also have everything greater than or equal to 1. So this must have come, I usually look at my positive one to help me write it. This means x must be, the absolute value of x must be greater than or equal to 1. So that way when I dropped it, if I were to solve, I would have to say x is greater than 1, and x is less than or equal to negative 1, which is exactly what I have in my graph. All right, looking at this one down here, so notice 3 and 7, kind of our median number is 5, and it's 2 units away from 5. So the way that I help myself do that is I want the difference to be less than 2, right? All of these are less than 2 and less than 2 units away. So from 5, so the absolute value of x minus 5, I want that to be less than or equal to, not equal to, just less than 2. So here, I'll rewrite this. I'm sorry. My B. So again, absolute value of x minus 5 is less than 2. I don't want it to be any more than 2 units away. So again, you can check your work. Always check your work. I have to check mine still. So if we set this up like we want to solve, and then I would add 5, so x is less than 7. X is greater than x is greater than 3. Plus 5, plus 5. All right, so less than 7, greater than 3, greater than 3. I know I have that set up. That is my inequality, and this was my inequality on the other one. All right, hopefully that helps. As always, I am here for you guys anytime that you are available to come in. Remember, especially if you're in blended, I am here every Monday, Wednesday, Friday. I'm in my classroom. I'm here ready to help you answer questions. And you'll get better at doing the math. All right? Keep your head up. Keep working hard. Love you guys. I'll talk to y'all soon. Bye-bye.